Okay, so in this presentation, I will be presenting about the science class presentation for Class B by me, Nyein, very sleep deprived one since I woke up from 1 a.m. to 5 p.m. for this presentation. I will be presenting about Chapter 10, Space Systems, and in this chapter we learned about the following titles. We learned about the age of Earth, the solar system, interactions between Earth and the solar system, and the universe. So for the first title, the age of Earth, it is estimated that the Earth formed around 4.6 billion years ago. Scientists use three major types of evidence when determining the age of Earth. The three are landforms, mainly sedimentary rocks, fossils, and radiometric dating. The first one is sedimentary rocks. Here's a picture I found on the internet for sedimentary rocks. One process scientists study and use is the formation of sedimentary rocks. As weather material settles over time, layers of sedimentary rock are formed. As new sediments are added to the top, you can assume that the bottommost layer is the oldest one. As you can see, as with the arrow pointed, this will be the lowest one. And for the next one, it is fossils. Fossils are remains, shells, or bones, or evidence left behind by dead organisms. Fossils are most often found in sedimentary rocks, and the age of a fossil can be determined from the layer it is found in. The opposite is also true, as finding a fossil whose age is already known provides information about the layer it was found in. And here's the example of a fossil that I found on the internet. The next one is radiometric dating. Radiometric dating is the use of radioactive isotopes to determine the exact or absolute age of objects on the Earth. Commonly used radioactive isotopes are uranium-235 and carbon-14. I hope that's how I pronounce it. The amount of time it takes for an isotope's atoms to change into another element is called the half-life. Uranium-235's half-life is 1 billion years, meaning after 1 billion years, half of the uranium-235 atoms in a rock would have turned into lead atoms. After 2 billion years, only a quarter of the original amount of uranium-235 atoms would have remained. This process would continue at the same pace until there is nothing left. By looking at the remaining number of uranium-235 atoms, scientists can determine the age of the rock. This is the process known as radiometric dating. The next one is the solar system. Our solar system is made up of the sun and all objects that orbit the sun. The sun is the star located at the center of our solar system, as you can see in this picture. Planets in the solar system. The planets that orbit the sun are the following in order of the distance from the sun. They are as follows: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The planets are divided by an asteroid belt in between Mars and Jupiter, which separates the planets into two groups. The four planets closest to the sun have rocky surfaces and are known as terrestrial planets, whereas the four planets farthest from the sun have gaseous surfaces and are known as gas giants. There's also a third category of planets, dwarf planets, which are much smaller than terrestrial planets. One example is Pluto, the ninth planet of the solar system. The next is moons, asteroids, and comets. Any natural object that in space that orbits a moon is called any natural object in space that orbits a planet is called a moon. Earth has one moon. Some planets like Mercury and Venus have no moons, and other planets like Jupiter or Saturn have multiple moons. Asteroids are large, irregularly shaped chunks of rocks. Although asteroids exist throughout the solar system, most are found in the asteroid belt that separates gas giants and terrestrial planets, which I mentioned before, between Mars and Jupiter. Comets, on the other hand, are made of frozen gases and dust particles, which are usually smaller than asteroids. Some orbit the sun continuously, while some orbit the sun once and then travel up into space to God knows where. Interactions between Earth and the solar system. Earth's rotation and revolution. Earth orbits or revolves around the sun. Earth completes one revolution around the sun every 365 and one-fourth of a day. 1/4 days. We call one revolution of Earth a year. Earth also spins or rotates on an axis. Earth completes one rotation every 24 hours. We call one rotation of Earth a day. Okay, the next one is high and low tides. The daily rises and falls of the ocean levels are called tides. A high tide occurs when the ocean reaches its highest point on the shore. A low tide occurs when the ocean reaches its lowest point on the shore. Tides are caused by the pull of the moon's gravity as Earth rotates. As the moon rotates, its gravity pulls on the water in the ocean. This causes the ocean to bulge on the sides closest and opposite of the moon. Areas within the bulge experience high tides, while areas outside the bulge experience a low tide. Spring and neap tides. As the moon has an effect on tides, so the sun does too. When the sun is in line with the moon, but they both pull the ocean in the same direction. This causes extra high tides and extra low tides, called the spring tides. When the sun and moon are perpendicular to each other, they both pull the ocean in separate directions, which can cause only minor differences and high and low tides. The universe, stars, and constellations, the total of all matter, and I forgot a T, and energy that exists in is called the universe. The different objects that exist in our solar system are found throughout the universe. The universe contains many other solar systems as well as other types of objects. Our sun is a star. A star is a ball of gas that produces its own light and heat. A constellation is a recognized pattern of stars in the night sky. Due to Earth's orbit, different constellations are visible at different times of the year. Next one would be the universe, galaxies. A galaxy is a massive group of stars, gas, dust, and dark matter held together by gravity. Our solar system is part of the Milky Way galaxy alongside 200 billion other stars. The universe is estimated to contain at least 1 billion other galaxies. There are different shapes that galaxies can have. Some examples are spiral galaxies, irregular galaxies, and elliptical galaxies. On the topic, the Milky Way is a spiral galaxy. The age and development of the universe. Scientists believe the universe formed 10 to 20 billion years ago. The most widely accepted model of how the universe came to be is the Big Bang theory. According to the theory, all of the matter and energy in the universe was contained in an area the size of an atom until an enormous explosion, the Big Bang, caused the matter and energy to rapidly expand outwards. Scientists believe the universe has been expanding since then. Age and development of stars. Stars vary in composition, size, and age. All stars, however, follow the same basic life cycle. A star has 4 phases, which are the following: the birth state, the main sequence state, the aging state, the old stage, and the death state. Size of a star. A star size is based on the total amount of energy and gravity it has. If it has a higher amount of energy whilst having a lower amount of gravity, it will be a supergiant. If it has a high amount of gravity whilst having a lower amount of energy, it will be a red giant. Small and medium sizes are known as red giants. Meanwhile, massive stars are known as supergiants. Is that an issue? Okay. So the birth and main sequence states: a star forms in a cloud of gas and dust called a nebula. Gravity causes some gas and dust to pull inward, forming a protostar. A protostar then turns into a main sequence star. The fusion of hydrogen atoms into helium causes main sequence stars to release heat and light. Old or aging state and death state. Older and aging state, a state achieved after a star can no longer produce energy. Once a star can no longer produce energy and no longer has fuel, it will enter the death state. Death state, a state at which a star can no longer maintain energy production. If it is a small or medium star, it will begin to slowly stop glowing. If it is a massive star, it will end up in a supernova, imploding upon itself. The next one would be death of small to medium-sized stars. Once a small to medium-sized star enters the death state, it will gradually cool down. Its outer layer will slowly crumble away. This process is called a planetary nebula. They will stop glowing and eventually become a black dwarf. Continue on, it will become a white dwarf. A white dwarf is a star that is close to dying out, and eventually it will die out. And the death of a massive star, when supergiants enter the death state, it is quite contrary to the death of a small to medium-sized star. Firstly, the supergiant will continue to heat up, then, due to the extremely large amounts of energy, its outer layer will crumble away at a fast pace rather than the slow pace of a small to medium-sized star. This process is called a supernova and only occurs with supergiants. The remaining core can have 2 separate outcomes. If the remaining core has a large amount of gravity, whilst being a small core, it will become a neutron star. If the remaining core is large with very little gravity, it will begin to pull in nearby substances such as gas, dust, and even light itself, and it will become a black hole. And that is all. And that is the end of my presentation. Thank you for listening to me rant about this very quickly. And that's it.
Alright, so first of all, I would like to say thank you for your hard work and presentation, but I have to give you some advice. Please slow down your talking. You have to talk a bit slow since I don't understand some
Yes,
of the
but
words.
I was at a rush with my battery power. That's why I was quite rushing it.
Alright, so I've got a few questions.
Yes.
So I heard you mention Big Bang Theory. So where's the most complaining piece of advice that support the Big Bang Theory?
Well, I can't really say that since I did not go deep I did not research that big into the Big Bang Theory. I just took a bit of information from the notebook. But if I had to say, the most supporting part about the Big Bang Theory would be the fact that the universe will be expanding. I think that would be the case of why I think the Big Bang Theory is the most supported one. But I'm not sure about that since I'm not that knowledgeable about this yet, this topic
All
yet.
right. Okay, all right. So this will be the last question on how might studying other planets in our solar system help us better understand the potential futures of Earth's climate.
Uh, I'm not sure how to answer that either. I don't If I had to be honest, I don't see the point of learning Earth's climate through the other planets since I don't know how it has any relation to Earth. And mainly, as I said before, I'm not that knowledgeable about this topic, so I have really don't really can't really answer that much of a theory, or that much of a question, that big of a question for this type of situation or topic.
All
Thank you
right.
for asking, though.
Thank you for answering my questions.
Yes, thank you for accepting my answer, even though it's not that great.
ဒီသမီးထုတ်မေးပြပါအောင်သမီး
ဟုတ်first of all အနေနဲ့PowerPoint လောက်ရတာကောင်းတယ်ဒါပေမဲ့ရှင်းပြတဲ့အခါမှာဖြည်းဖြည်းလေးနဲ့မှန်မှန်ရေးစီပြောစီချင်တယ်ပေါ့နော်မနေနားလေအောင်လိုက်နားထားရတယ်ဒါပေမဲ့ it's okay so မေးချင်တာကဒီ slide 17မှာပြောသွားတဲ့အထဲမှာပေါ့နော် age နဲ့ပတ်သက်တာကိုမြင်လိုက်တယ် so what kind of age ဘယ်လိုမျိုးကိုပြောချင်တာလဲအဲ့ဒီဟာ
It was stars and not the age of anything else. If I look back, it will mention the age and development of stars. It would be the age of the stars and how they grow over time. I think it's mainly about this time the star takes to accumulate total dust and particles, but mainly it will be talking about the age of stars and not anything else.
Okay thank you
So I would say your presentation is impressive. And like the question that I want to ask is, what is radiometric dating and how does it work?
It would just be using half-lives to determine an exact age of something. For let's say, for example, the Earth. The scientists would use a rock, mainly. I think I have to look back at my own presentation for this. I don't even remember the name since I rushed through it so fast. It would be using sedimentary rocks, and they would just find uranium 235 in it, and they would determine the half-life of it, or they would just calculate with the half-life of uranium 235, which is 1 billion years, and they would determine on how much lead there is in said rock, because lead, not I don't know what I just said there, but I meant to say the lead. They would have to calculate with the amount of lead that is in the rock, since uranium 235, once its half-life is gone, it will eventually turn into lead.
Okay, so thanks for answering my question.
Yes, thanks for asking.
Okay, first of all, thank you for your presentation. Even though you speak really fast, the concept was so amazing and so impressive.
Yes, I will ask the teacher to spread it to everyone, just so that they can understand it better, since I just rushed through it.
Then my question is,
yes,
what's the difference between a star and a planet?
A star and a planet, the difference is that planets do not generate their own light as stars do, and planets are made of rock or gases, while stars are made of a lot of random things that are combined, such as dust particles, and then gases, as well as gravity and a lot of heat. That's the difference between planets and stars, mainly the fact that planets do not have as much of a high amount of heat as stars, as well as the surface is not the same. The entire thing made of stars and planets are not the same. Also, I have no light.
Thank you for your excellent explanation.
Yes.
သမီးအေးတော့လာမြင်သမီး
May I know how did the foresight found Chemi as man as you know?
Could you repeat that?
Can you hear my voice?
Yes, I can, but could you repeat that?
Pore size 膠片有轉㗎，先不攞啦，嗰啲錢係咪？
You mean fossils?
Yes.
Fossils would be when animal remains are discovered through sedimentary rocks, more or less when they are how should I say preserved by the earth in natural landforms, such as when they are submerged by the earth and they do not decompose, such as bones. I think those are what fossils are, and fossils are mainly shells, so it would probably be some snail that died and then eventually billions of years later the shell that it remains that remained would be discovered by us humans and it would be a fossil. It would mainly be how it is preserved in the soil or ground and how old it is that determines what a fossil and how it came to be is.
Thank you for answering my question.
Yes, please let me know if you didn't understand anything. I truly am sorry for rushing through it.
Nyein.
Okay. First of all, I love your presentation. It is kind of a little fast, but for me, I can catch it. And the question I want to ask is like, the art is like a whole mass before it contain water and art. So, what is the state of the art before it contain water and land?
Well, I'll take some inspiration from Montejar's presentation earlier. It was a boiling hot sphere in the universe where there was nothing but volcanoes erupting everywhere and magma flying over and about. I think it would just be a kind of rocky surface planet with a lot of volcanoes and magma, as I said before. A very heated one at that. And I don't think there will be that much of a crust as we have it right now. So I think the just standing on it would be very hot. So probably like a boiling pot, but very large and in a planet shape.
Okay. So the next question is, how do you think that kind of state will be what kind of aging like main sequence or older planets, like some kind of like that?
For our Earth, I think back then it would just be the birth state, mainly because there was not that much vitality as we have it right now. And back then, I believe it was the era when uh, flying rocks were still hitting each other and making planets, colliding with each other. I mean, and making planets. So I think it would just still be in the birth state instead of main sequence or aging. If we are talking about the current state, I think our Earth is still in the main sequence state.
Okay, thanks for your answering my question and
Yes.
good luck.
Yes, thank you for your questions as well.
Yes, Chet. First of all, I was really amazed by your pronunciation throughout your presentation. It was clear, although it was a bit fast. So, my question is, what do you think what the main purposes of examining like different types of rocks are?
I think the main purpose would be to find out the age of the Earth, as was said in the presentation. But on a personal note, I think it would just be to learn more about how our Earth came to be and how the past of our Earth is, such as how rocks were or how things were back in the prehistoric era, or maybe back in the era was it I just said earlier, the birth state, I guess, of our Earth. I think that would be the cause of studying rocks in our planet, to learn the age of the Earth and how things were back then.
Yeah, that's for your answer.
Yes, thanks for your question as well. And lastly, Moteja.
Can you hear me, Nyein?
Yes, I can. Please continue.
From your point of view, do you believe the Big Bang theory? If you believe, why?
I'm not sure how to reply on this since I'm not that informed about it, but I think I do believe in it since it would give a rational explanation on how the universe came to be. I don't think I could just accept the universe as just God created it or anything unbelievable like that. So I think the Big Bang theory is correct because it gives a rational rational explanation on how our universe, our vast universe, came to be, and how big, how truly big it is. And Nyein, please ask another question.
Yeah, so the next question I want to ask is like, if the outside is same as a Mars, the Mars planet, yeah. So what do you think? What will happen if our planet side is like Mars planet side?
Oh, you mean like Mars? If our
Yeah.
planet is like Mars,
No,
I
no,
think.
like same side as a Mars, not like Mars planet.
Same size as a
Yeah.
Mars. I think there won't be that much of a difference, except that we will have a lot of less area to work on, and a lot of less people will have to live because in the end there will be overpopulation, and I don't know how, but we will have to control our population. I think that would be the main issue. And talking about separate ecosystems, then I think a lot of ecosystems would be very smaller, and this could cause some territorial dispute among animals, like in the wild, just wild animals alone. Not even mentioning about human territories, and there would be a lot of wars as well, since there's little space on the Earth. Because it would be, I think, a lot less smaller than Mars. I mean, Mars is a lot less smaller than our Earth. So I think that's what I believe.
Okay, thank you. So the next question is like, if there is a black hole, like some planet near our Earth, what will happen?
We will be disintegrated in, I think, at minimum a decade, more or less 5 years, less than 5 years. That we will be eradicated from the face of the universe unless we find some way to travel away or fly to some distant universe. But if there was a black hole near our Earth, then we would just be sucked in, and we won't even know what will happen. We would just become noodles we won't even be able to be seen by anything else. That what would happen, and it will probably suck in our sun as well, eventually causing our sun to go supernova, and then our entire solar system would go boom. That's all I can really say to your question.
The next question I want to ask is like, there is a lot of like multiverse, like there is a solar system and there will be a solar system and then like Milky Way and the galaxy. So there is a lot of galaxy and that we didn't discover. But like, do you think there is some kind of same planet like our Earth in different universe?
I mean, technically there could be, but it's very unlikely since, well, technically there could be in the vast universe, since there are a lot of universes, I mean, galaxies in the universe, and there could be an identical Milky Way with the identical people, with an identical Nyein and an identical Nyein and an identical YDP Academy in that universe, but there's a very low chance of it happening, and there's a very low chance of us discovering it. So I would just say that there won't be an existence for that, but there is a probability, very low.
Yeah, thank you for answering my question. I asked you a lot.
That was the worst. That was the best experience I had. 5 questions in a row. So, teacher, may I go back to that tablet now?